Okay, let's go and switch over to that screen. I think should be ready. So we have our function, which is y equals square root of x squared minus 2x plus 1 squared minus 2x plus 1. And that is a kind of amazing shape. It's a V shape, which was not what you might have expected, but nonetheless, it is. And I can look at that shape now, and I can see that since the sides go up forever, that the domain here is everybody. There isn't any problems. And we are good. The domain is minus infinity to infinity. Now, if the function was a nice easy one, like 2x minus 1 or something like that, or x cubed 5x, you should be able to just do those the usual way. But if it's something really ugly like this, you might want to sketch it. And it looked like that. And I'm pretty sure that number there was 1. And you can see that it basically travels in both directions forever. And that guy there is totally fine. So it's good. Okay. Let's do another one. Let's do fractions are always the scariest ones to do. So let me see if I can find a fraction one. Yeah. Suppose we have f of x is this guy and g of x is that guy. And we are going to find log of x. So that's f g of x. That's going to be f of 3x add 12. And the rule for f is 2 over what you give me, which is this guy. So we now have our formula for log of x. It's this guy. Well, I'm looking at that and I'm saying that's a rational function. I hope you can look at that and say immediately that when x is -4, you're going to have problems, because when x is -4, the bottom is 0. And that in turn gives me my domain. The domain is anybody I like, as long as you're not -4. Let's switch the order. Let's do a golf of x. That's g f of x. That's g 2 over x. And that becomes 3 lots of 2 over x add 12. Now you could make it slightly pretty. You could do that. Now, do you see in this case, the only guy that's going to cause trouble would be when x is 0, right? So I know the domain is everybody, but don't use 0. And we are good. Now let's do 2 more. Let's do a log of x, which is g of x. So we're repeating the rule for g. The first time you just do a simple substitution. But the second time, this isn't 3x add 12 anymore. This is 3 times what you give me add 12. So it's 3 times what you give me add 12. And then I do a bit of style points on it. And I now have log of x. But that guy is got no problems. I can find 9x plus 48 no matter what I do. And so I'm going to be able to get from this guy that the domain is everybody. There are no restrictions. Any value of x will do. But this last one is a head scratcher. F of x, right? That's fourth. That's f of 2 of x. And now what's the rule for f? 2 over whatever you give me. So 2 over 2 over x. I'll put a little bracket around that just for emphasis. Now, obviously, I'm not going to leave it like that. I am going to tidy it up, right? But I'm also going to be aware that there are a problem. Would you agree that x equals 0 is a problem? Because 2 over 0 is going to make that bottom weird, and we can't use weird. So I already know what the domain is, even although I haven't simplified it. In fact, sometimes it's a good idea to look at domains before you have simplified your answer. So any value of x except 0 is your domain. Now let's make this thing pretty. 2 over 2 over x, right? You can think of that in two different ways. This is one way to think of it. It's 2 divided by 2 over x, which becomes 2 times its reciprocal. Cancel all the 2's, and you get x. And so that is the final answer. Or you could look at it in this way. I have a fraction with fractions in it. So I'm going to use this little clever technique in algebra. And basically, I'm multiplying this fraction by a special version of 1. As long as you're multiplying a fraction by 1, you do not change its value. You only change the way it looks. So how's that going to help me? Well, 2x on the top. That guy times that gets me 2. Cancel out the 2's, and now you have x. So there's two ways to simplify that. And you do need to simplify your answers as much as possible. Here we go, I hope. Let's try the square root and a fraction. Let's see what they can do. So there's the square root and a fraction. And there's my square root. Well, actually, let's take out the square root. That's probably too much work. Let's just do that. It's a little bit nicer, right? Okay. We want to do fog of x. F g of x. F of, oops, the head there, x squared minus 4x. Square root of x squared minus 4x. That one is quite difficult to get its domain, algebraically at least. Although later on we'll actually show you how you can do that algebraically. But right now, we're just going to do it by using Desmos. So if you bear with me for a few moments. Here we go. Let's show you what that graph looks like on Desmos. Whoa, would you look at that? At 0 and at 4, function starts and finishes. But it's got a big gap in the middle. Numbers between x0 to x equals 4 don't exist. So my domain is anything that's less than 0 and anything that's bigger than 4. Right? So anything less than 0 and anything bigger than 4. So less than 0 and using it, and bigger than 4 and using it. Let's do it the other way around. So it's going to be 1 over the square root of x squared, take away 4 lots of the 1 over the square root of x. Now, I'll tidy that up in a minute, but right now, I'll leave it alone because it does give me information that I need to figure out this domain. And I'm looking at fractions and I'm just saying to myself, x equals 0 is a bad guy, but everything else is okay. So just don't use 0. Now, to make it look pretty, 1 over the square root of x times 1 over the square root of x gets you 1 over x, and multiply these two together, you get that guy. Nothing very nice, but that's as good as it's going to go. Okay, so there's a couple of other things that we need to do, and then we'll be finished this section as well. And that's everything for week 3 covered. And we're still doing compositions of functions, but we're now going to look at a situation where you need to find fogs and goths of numbers, but the numbers are going to come from tables. So I'm going to shoot over to here, show you a table that's set up. So along the top are the values of x. Then you have the value of the function. So when x is 1, f of 1 is 2, when x is 5, f of 5 is 6, and so on. And then in red, we've got the values of j. So if you wanted to find GOG of 2, for example, okay, so go along here. Here's 2. What's GOG of 2 equal to? GOG of 2 is equal to 5, right? So this is going to be g of g of 2. Which I forgot to put in. Okay, there we go. So that's what the calculation is going to look like. Now, g of 2, there's 2. There's the value for g of 2 is 5. So that thing is equal to g 5. Now, g of 5, well, here's 5. What's the value of g when x is 5? It's 4. So this is equal to 4. So what you do now is you put in the answer. And there you go. Okay, so what are the last questions that we're going to deal with? These are application ones, right? So these are stories, 21, 20, 20 and 21. And they go and they give you some information, and then you're meant to somehow or other generate a formula for it. So here goes. A stone is dropped into a lake, creating a circular ripple that travels outwards at the speed of 85 centimeters per second. So basically, they're telling me that you've got these circles getting bigger, and the circles are going to change by the speed of 85 centimeters a second. So what would the radius be, right? So g represents the radius, and the radius would simply just be 85t, right? Because at the 1 second mark, the circle was at the radius 85. At the 2 second mark, it would be 2 times that, 3 seconds, 3 times that, 3 seconds, 3 times that. Now, part B, find a function that models the area of a function in terms of its radius r. Well, as far as I remember, a circle is pi radius squared. Now, that is the radius function in terms of r. But what would fog be? Well, fog would be this guy and that guy. So what would that end up being? Well, it'd be pi times the radius squared. And what you need to do now is basically find out what 85 squared is as a number, and you'd have that number, pi t squared, and you'd be finished, and then you choose one of these. Now, last one, a spherical weather balloon is being inflated. The radius is increasing at the rate of 4 centimetres per second, do the surface area. Right, you may want to look up the formula for the surface area. I can tell you it's 5 pi radius squared. And if the question was, what's the surface area using the variable r, that would be correct. But it's using the variable t. Now, what do we know about the radius? Well, it's increasing at the rate of 4. So that means this radius will be 4 times t. So what you need to do is multiply that all out, which is what, 16t squared, 16 and 4 is 64. So you get 64 pi t squared, at least in my example. And that is us. We are finished. Good luck. Office hours, just to remind you, are at 10 a.m. and sometimes I'll be in the college, in which case I'll send you an email telling you that I'm there. If I don't mention that, it means I'll be doing it using Zoom only. Okay, so goodbye and hope to see you soon.